Now let's do some problems. The induced EMF in a coil. A circular coil with a radius of 10 centimeters has 40 turns. The coil is oriented perpendicularly to a magnetic field whose initial magnitude is 4.2 Tesla and is directed into the page. The magnetic field vanishes in 0.50 seconds. A. What is the initial magnetic flux in the coil? B. What is the induced EMF in the coil? C. If the net resistance of the coil is 5.2 ohms, what is the magnitude of the induced current in the coil? D. What is the direction of the induced current in the coil? And E. What is the rate of thermal energy generated by the coil? Start by listing the givens. And the first thing we do here is convert centimeters to meters. And we need to find the initial magnetic flux. Well, let's find the area of the coil. We've given the radius, so the area is pi r squared. Here's our r in meters, and we get 0.03 square meters. Since the magnetic field is perpendicular to the coil, the magnetic flux is maximum. So we just need to multiply B times A, substitute in our givens, and of course our found area here, and we get the initial flux is 0.13 Webers. What is the induced EMF in the coil? We will use Faraday's law of induction right here. Okay, we have 40 loops, 40 right there, 40 windings. Our final flux is 0 because the magnetic field disappeared. Initial was 0.13 Weber, that's what we calculated. And here's the time over what that occurred at. So we do the math and we find it's 10.4 volts. And notice, we just use Faraday's law to find the magnitude of the induced EMF. We don't use the negative sign then. Now we need to find the magnitude of the induced current where we're given the resistance of our wire. And we get to use Ohm's law. Voltage over resistance, or EMF over resistance. Remember, EMF acts just like voltage here. We substitute in our givens and our found, and we find we have a current of 2 amps. What is the direction of the induced current in the coil? The original field decreases. Therefore, the induced field, which is in blue, will be in the same direction, which is into the page, opposing the change in the original field. It wants to keep its original strength. Apply the right-hand grip rule for the induced field. Curving your fingers, your 4 fingers, into the page within the loop, which make sure you use your right hand, your thumb should be pointing in that direction. That means the direction of the induced current, the same as the direction of the thumb, is clockwise. What is the rate of thermal energy generated by the coil? Well, power is another name for the rate of thermal energy generated, and that will be generated by this induced current in the wire. And power is IV, where V is voltage, but again, voltage and EMF are interchangeable here. Substitute in our current, our EMF, and you get a power, or the rate of thermal energy generated, is 20.8 watts.